Today we will take a look on how to implement terrain movement of a character with correct physics. I already did a video on how to implement a three.js character controller with the focus on animation and movement on a flat plane. Now I will reuse that character controller and combine it with a physics engine to make the character move on an uneven terrain and interact with physical bodies. I have chosen the physics simulator engine Rapier. This engine has a 2D and a 3D variant. It is written in Rust and can be loaded as a WebAssembly module in our JavaScript web app. We have the visual three.js world and the invisible rapier3D physical world, and we must glue them together. The usage of rapier3D in JavaScript is as following. First, you load the rapier3D WebAssembly module. After it has been loaded, you initialize the physical world with a gravity vector. Then you add bodies to the physical world. And then the game loop is started where the physical world is updated continuously. When you add a body, you must make some decisions. You must choose a rigid body type. Basically, there are three types. The dynamic body is which is affected by gravity, forces, velocities, and so on. The static type is not affected by physical forces, but affects dynamic bodies. This type is suitable for ground and walls. Then we have the kinematic type, which is also not affected by physical forces, but can be moved. This type is suitable for moving platforms, and I will use it for the character controller. You must also choose the collider shape. There are several basic collider shapes available, such as cubes, spheres, and cylinders. Many of them have round edge variants. Also, there are ways to create complex colliders with meshes and other data. In my example, I will stick to basic shapes and the Heightfield, which works similar as a height map and is suitable for ground terrain. Once you have chosen the rigid body type and the collider shape, you attach both together and create a collider in the physical world. From now on, the body is interacting in the simulated physical world. Combining three.js and rapier3D is easy. Here is an example how to create a 3D box with physics. At first, I create a regular three.js mesh object and add it to the three.js scene. Then I create a rapier3D box collider with the same size as the three.js box and add it to the physical world. Store them as a couple somewhere so we can keep the relation between both objects. The game loop combines the physical simulation steps and the rendering of three.js. I iterate all rigid body and mesh couples to get the rigid body state. That is the position and rotation of the physical body. And I apply that information on the three.js mesh object. And also, of course, I tell the three.js renderer to render the current frame. Adding some more static and dynamic objects reveals that we now have a simple 3D engine with physics. A good challenge is to create a terrain with a height field. The height field stores height data in an array. Each height entry corresponds to a point on a plane. With a given scale on x, y, and z axis, this can be used for physical terrain simulations. The rapier3D height field can be combined with the three.js plane geometry. First, I must know the scale and the number of subdivisions of the field. Then I can create a simple three.js plane geometry mesh. For now, it is only a flat plane. Then I can iterate all vertices of the plane geometry and add a random height value. While I do that, I map each vertex to a column and row index of a matrix and store the generated height value. The rapier3D height field requires to have the data to be in a column major order matrix array. So I generate that array and provide it along with the scale to create the corresponding height field collider. And just like that, we have a randomly generated terrain. The next challenge is to implement a physical character controller and make it move on that terrain. I am reusing my character controller from the previous video. Right now it is not colliding with any of the physical bodies. So I create a kinematic sphere-shaped physical body which is invisible. It is just there to represent the character's body shape. Instead of moving the character model, I move the kinematic body and then update the model's position accordingly. Having that, my character can now collide with dynamic bodies, but it can go through the terrain. The terrain is a static body and the character has a kinematic body. The types do not collide. And also my character is not affected by gravity. To fix that, I must apply gravity on the character body by myself. And also I must detect collision with the terrain by myself and keep the character above the ground. The gravity is very easy implemented. Just update the character body position on the y-axis by using the gravity constant and multiply it by the delta time. With that, the character is falling through the ground. To fix the ground issue, we must be able to detect a collision with the terrain. Like any other physics engine, rapier3D provides raycasting. With that, we can cast a ray downwards from the center of the character body and check if the ray is hitting another physical body. On a close hit, we can correct the body position upwards. A ray has an origin and a direction vector. Every frame and while the character body is moving, I update the ray origin and cast that ray. When we have a hit and the distance to the hit is below a certain threshold, I move the character body upwards to stay above the collision. This approach is sufficient for my simple terrain movement use case. Now that concludes the physical character controller. This can be further optimized, like adding more rays to have more accurate hit detection. For now we are able to build simple levels.